Greetings everyone. My name is Vemuri Rohan, and as part of my operating systems project at Lovely Professional University, me and my team have made an automatic deadlock detection tool with recovery mechanisms using Flask Web API and vanilla JavaScript. And today I'm here to present you our project. So let's dive in. So this is our automated deadlock detection, avoidance, and recovery simulator. The goal of this project was to take deadlocks, which are usually theoretical, and make them interactive and visual. We built a system where you can simulate processes and resources, detect deadlocks, and apply recovery strategies in real time. A deadlock happens when processes are stuck waiting for each other's resources in a circular manner. The challenge is that detecting and resolving deadlocks in real time is not straightforward, especially when multiple instances of resources are involved. So, our objectives were to build an interactive simulator, implement detection using DFS and matrix method, apply Banker's algorithm for avoidance, and include recovery strategies like terminate, rollback, and preempt. So these are the main features of our system. We have an interactive matrix editor, live graph visualization, and step-by-step trace logs. We also implemented recovery options like terminate, rollback, and preempting the process. Additionally, we added preset scenarios like the circular deadlocks and safe state, along with a randomizer, so users can test different cases easily. This is the overall architecture of our system. The front end is built using HTML, CSS, and JavaScript, where users input matrices and view graphs and traces. The backend is a Flask API that runs all the algorithms like detection, bankers, and recovery. All communication happens through JSON requests. So the front end sends data, backend processes it, and sends results back. So we kept computation on the back end and visualization on the front end. So these are the main algorithms we use for the project. First, DFS on the wait for graph, which helps detect cycles between processes. Second, the resource allocation matrix method, which is the main algorithm that confirms deadlocks by checking which processes can actually complete. And the final third one, which is a banker's algorithm, which is used for avoidance by checking if the system is in a safe state. So DFS gives visualization, matrix method gives correctness, and bankers prevents unsafe states from taking place. In conclusion, we successfully integrated detection, avoidance, and recovery into one system. One important takeaway is that while graphs help in understanding deadlocks, the matrix method is the actual authority for multi instance systems. The recovery module shows how the system can return to a safe state. Overall, this project helped us connect theory with practical implementation. Thank you. So to demonstrate our project, I have taken this scenario, which consists of a three-process circular deadlock, which has been identified as an unsafe state by the application. So to resolve this, I will navigate to the recovery section of the application, where it suggests me whether to terminate, roll back, or preempt, and also suggests me which process to take the according action on. So here it says to preempt the resources, and the victim should be process 0. So I have selected process 0 and I clicked on preempt resources. So there's that deadlock resolved and the system has gone back to a safe state, as you can see. As you can see, there are other sections here as well, like the simulate section, which lets us simulate scenarios of our own choice, as well as the banker's algorithm, which works as a deadlock prevention technique by showing the safe sequence in which the flow of a system should occur to prevent deadlocks. Thank you for letting me present this project, and I wish you all a good day.